Hi everyone, welcome back to my channel. Today I'm going to show you how to perform downscaling using the Kriging function from the KrigR package. If you work with spatial data and want to disaggregate value across a landscape, this method is a powerful tool to add to your analysis toolkit. We'll walk through a quick example from loading the necessary package to generate a Kriging surface. So let's dive in. The first thing we need is a raster of data that we want to disaggregate. So I've got here a precipitation raster. If we take a look at it, we can see that I have many layers, and each layer is referred to a date. The first layer is the 1st January, so the month of January of 1993. So our goal today is to lower the resolution of these layers. So to do so, we need to load the KrigR package and use the covariate setup function. In this function, we need to specify that we want to train with the precipitation raster, so only use the first layer of the precipitation raster dataset. We also need to specify a target resolution. I know from experience that I can't go lower than this, so the initial resolution of my precipitation raster is 0.1, and with this setup I can go up to 0.009. So let's use it. Let's use this specific resolution. I want the result of this function to be saved in a covariate folder on my computer, and I also want to keep it in my global environment. So if I go ahead and run this function, the first step that this does is to load the covariate. It usually takes a minute, but in my case I already have this GMTED 2010 on my computer, so that doesn't have to be loaded again. The second step that it does is to prepare some covariate training and target for our Kriging function. So the second step here is to use the Kriging function of the KrigR package. We need to specify the dataset, so we want to Krig a raster object, which is the first layer of our precipitation raster here. We want to specify the covariate training and the covariate target that was created in the previous step. We want to use the elevation as a covariate to downscale the precipitation data with the number of nearest observation to be used. So each point will use 40 nearest observation. This is something that is used in the Kriging calculation underneath. I tell this function that I want to allow the 3 core of my computer to be used for this process, and this is going to be saved in an export folder on my computer with this specific name. So if I run this function, it is also a function that takes a bit of time, but as here I have specified only one layers, it processes really quickly. So if I want here to plot the result, I can see here that I have a raster that contains exactly the same area with a lower resolution. To give it the same shape that the precipitation raster initially had, I need to go back and use exactly the same boundaries that was used to create initially my precipitation raster. So I know that this precipitation raster is in the shape of Sounds Quebec, which is a region in Quebec. So if I load tidyverse and go ahead and load the shape, which is this one, I can mask here. I can use the function mask to crop the unwanted area of my downscale precipitation raster in the shape of this polygon. Now that I have downscale and crop my raster, I now have a raster that is exactly in the same shape that my initial raster was, but this one has a resolution of 0.009, and if we compare it to the initial raster that has a resolution of 0.1 degree, we can see that there's a huge difference in the way we can visualize the data. So that's it for the KrigR package or the Kriging function. So if you got any thought of question on this topic, drop them in the comment section below. I'd love to hear from you and help you however I can.